Imagine standing in the middle of a desert and saying, "We are building the tallest building on Earth right here." Not on a mountain, not on easy ground, but in Dubai where the soil is sandy, the heat is brutal, and the wind at extreme height can push a building like an invisible wave. This was the challenge behind the Burj Khalifa, a tower so tall that when you look up from the ground, your neck gets tired before your eyes reach the top. But the real question is, how did engineers build something that looked impossible? The first problem was the ground. Dubai's desert soil was not strong enough to hold the world's tallest tower. A normal foundation would never work for a building this heavy. So engineers built deep underground roots. They drilled huge concrete piles deep into the earth, almost like giant legs under the tower. These piles were connected to a massive concrete raft, which spread the weight across the ground. Think of soft sand. If you stand on one foot, you sink. But if your weight spreads out, you don't sink as much. That is exactly what the foundation does. But the ground was only the first enemy. The second enemy was wind. At more than 800 meters high, wind becomes a powerful force. It can shake the tower, create pressure, and make the building sway. If the tower had been shaped like a simple box, wind could hit it again and again in a dangerous rhythm. That rhythm could make the building move too much. So engineers designed the Burj Khalifa with a special Y-shaped structure. This design was not just for beauty, it was for survival. The three wings support each other like a giant tripod in the sky. As the tower rises higher, the shape keeps stepping back and becomes thinner toward the top. This trick breaks the wind. Instead of letting wind attack one flat surface, the tower's shape confuses it. The wind cannot create one strong, repeated pattern because the shape keeps changing. It does not fight the wind like a wall. It tricks the wind like a master engineer. Then came another nightmare. Concrete. In Dubai's heat, concrete can crack if it dries too fast. So workers poured much of it at night, when the temperature was lower. They used special mixtures and cooling methods to keep it strong. But even that was not enough. They had to pump concrete hundreds of meters into the sky. The pressure had to be perfect. If it was too thick, it could block pipes. If it was too weak, the structure could fail. Every part had to be tested and controlled. Now think about the cranes. How do you lift steel, glass, machines, and workers to a height where even helicopters struggle? Massive cranes climbed with the building as it grew. When the tower was finished, they had to be removed piece by piece. Then there was the glass. The outside had to survive desert heat, sunlight, and powerful winds. The glass system reduced heat while still giving the tower its futuristic look. A building this tall also needs air conditioning, water, electricity, fire safety, elevators, and emergency planning that work vertically. But many people don't realize this. The Burj Khalifa is not completely still. It can move slightly in strong wind. And that is not a mistake. That is smart engineering. A super tall building must be able to flex. If it was too stiff, the stress could become dangerous. So the tower is designed to move just enough to absorb pressure. The Burj Khalifa was not built by luck. It was built by mathematics, testing, planning, and human courage. It was built by solving one impossible problem after another. That is why this tower is more than a luxury building. It is a message. When human imagination meets engineering, even the desert sky is not the limit. The Burj Khalifa stands at 828 meters above Dubai. Before it became a building, it was an idea that sounded impossible, and then engineers made it real. If you enjoyed this video, make sure to like, share, and subscribe.